Number one, we have a system of equations that we need to solve. They're both already in slope-intercept form. I want to be graphing the top one in blue. Actually, the top one in red, that's what I usually do. Top one in red and the bottom one in blue. What am I doing? Top one in red, bottom one blue. So the top one crosses at 3. And from this point, I'm going to go down because this is a negative slope right here. So I'm going to be going down 2 over 3. And that's my point. So that's my line. I could draw my line right through those 2 points, put an arrow on it. My blue one crosses at -2 down here. Remember, this is your B value, your y-intercept value. So it crosses at -2. And from that point, I want to go, according to my slope, which is 1, I want to be going up 1 over 1. So up 1 over 1, up 1 over 1, and it keeps going right through there. So when we're asked to solve a system, we're looking for that common answer in both. Here's an infinite amount of answers for the top equation. Here's an infinite amount of answers for the bottom equation. There's only one answer that works for both. That's this point of intersection. And that point of intersection is 1, 2, 3, comma, 1. So the answer is the coordinate 3, 1. Or you could say x equals 3, y equals 1. If you wanted to double check that, all you have to do is plug it in. So number 2 is already done for us right here. I wanted to speed it up so we could get to the actual notes on this video. You get y by itself by subtracting x. What you do to one side, you do to the other. You're going to have y equals -x plus 3. There it is. Then you divide by 2, everything by 2 to get rid of the 2 and get y by itself. And we notice that we have the same, almost the exact same equation. This has the same slope, that has the same slope. The only difference is that one crosses the y-axis at 3 and the other one crosses at -3. So this red one crosses at 3, the blue one crosses at -3, but they both go down 1 over 1, right? This one also down 1 over 1. So what does that tell us? That the lines are parallel. If they have the same slope, the lines are parallel. So if we're looking for that single answer that works for all of them, or for the whole system, there is no answer that exists. So you either say no solution, or you do the 0 with the line through it, the no solution symbol. So it's up to you. You could put no solution, or you could put the 0 with the line right through it. Let's check out number 3. It's a little bit more fun. That one, the top equation, I'm going in red. It's already ready to graph. It crosses at -3. Put a dot right there at -3 on the y. And then from that point, you're going to go down 1 over 1. So from this point, you're going to go down 1 over 1. But the thing is, that's a really tiny line, so you're going to have to use that same slope pattern, but backwards. Instead of going down 1 over 1, let's go over 1, up 1, over 1, up 1. That way you could continue with the dots right there, extending it the other way, as far as you like. Anyway, there's my line. And let's go for the bottom equation in blue, this guy. This obviously has no number at the end, so I'm going to put a +0, just so it'll be clear that it crosses the y-axis at 0. And from that point, I have a slope that is 2 in front of x, so that's the slope 2 over 1. So you're going to go up 2 over 1, up 2 over 1. Now the thing is, you still want to extend it the other way so you could actually find the exact point of intersection, which will be right here. So instead of going up 2 over 1, use that pattern backwards, over 1, down 2, over 1, down 2, and you will get to that point of intersection right there. And that's your answer for this system number 3. And what is that coordinate? It's -1, -1, -2. So -1 for x, -2 for y. That's your solution to that system. Okay. Moving on to number 4. The top equation, I want to get ready to graph. I want to add 3x. I want to add 3x. So I'll have -2y equals 3x minus 8. And my final step would be to divide by -2. Divide by -2, divide by -2. So my final equation in red is y equals the negative sign on the 2. I'm going to bring it up to the middle, or up on top with the 3. and the negative 8 divided by negative 2 becomes a positive 4. That's my new equation in red that's ready to graph. Before I start graphing it, I might as well jump to the other one and get the other one ready to graph. So notice that my y value is on my right side this time. All I care about is getting y by itself. It doesn't matter if it says y over here equals mx plus b or y over here equals mx plus b. You could always rearrange it or switch it at the end. So let's get y by itself by dividing everything by 4. And we will have y on this side equals, if you reduce negative 6 over 4, that's negative 3 over 2 with an x. And the 16 divided by 4 is 4. Now let's write this a little nicer with the y on the left. Y equals, and the fraction is negative 3 halves. So negative 3 halves x, and it has a positive 4. This is a positive 4, so when I switch it, it has to be plus 4. Does that make sense? So what do I really have? I have this new system. It's not a new system. It's the same system. It just looks different. They're ready to graph now. Do I even have to graph? No, why not? It's the same slope. It's the same y-intercept. It's the same equation. It's the same line, right? If I graph the red one, it's going to cross at 4, and I'm going to go down 1, 2, 3, over 2. There's my dot. There's my red line. And if I graph the blue one, it's the same point at 4, and you go down 3 also, and over 2 also, and it's the same line. So when I'm asking for the answer, what would the answer be? Infinitely many solutions is your answer. Of course, you could go back and classify all of these. We've already had previous videos on classifying. This would be called a consistent dependent. Consistent dependent is when they're right on top of each other. When they intersect at one single point, that's consistent independent. When they're parallel, that would be inconsistent. Let's move on. So down here, it explains that graphing systems is really not the best method unless you're using a computer program or a graphing calculator. Because what if your point of intersection is the coordinate 79, negative 86? That'd be really hard. You'd need a super huge graph paper to do that, and it would take a long time. So unless you have a graphing calculator or a computer program, you really don't want to do what we just did above. So you're probably thinking, why did he teach us that? Well, it's the only way to get a true understanding of what a solution is to a system. So that's why we graphed. We're going to learn this method right now, the substitution method, which is also not the best method, but it is better than graphing. So step 1 to substitution, you can see it on your notes right there. It says pick an equation and solve for a variable. Okay, so we have 2 equations right here on this system. Instead of graphing, pick an equation, the top or bottom? Top? I'd go with bottom. Okay, and I'll tell you why. The step 1 is to pick an equation and solve for a variable. Yeah? So like, let's say you did pick the top. Which one would you like to solve for, x or y? And it doesn't matter which one you select. X. Okay, so if you did pick the top one and you wanted to solve for x, you would have to subtract 5y, and then divide by 2 and divide by 2, right? But now think about this. What if I pick the bottom equation? Because you could pick any one you want. I mean, technically you could use the top one. But if you pick the bottom one and solve for x, what do you have to do to get x by itself? Subtract 3y, and that's it, right? So in mathematics, there's always many roads to the same place. Just some roads are shortcuts. Some roads are quicker than others. So when I say step 1 is to pick an equation and solve for a variable, it's a good idea to think about which one's better to pick, the top one or the bottom one. The bottom one's better to pick because if I subtract 3y on both sides, I'll be done. This says x equals negative 3y plus 3. That is, bless you. Thank you. That's step 1 right there. You picked an equation, we picked this bottom one, and then we solved for x. So what do we have here? We have x equals negative 3y plus 3. Let's go back to the steps and see what else it tells us to do for step 2. It says substitute that value, or actually that variable expression, into the equation you have not used. All right? So we're going to substitute this variable expression. What variable expression? I'm talking about this guy right here. What does x equal? It equals negative 3y plus 3. So we're going to take the negative 3y plus 3 part, and we're going to substitute it into the equation we have not used. Which one have we not used? The top one. So I'm going to take this guy, and I'm going to plug it into the top one. Where do you think I'm going to plug it in? Into the x or into the y? Into the x. Right there. Y, actually x, not y. But y, okay, I'm confusing myself. I want to plug in this value into x because x equals this. Does that make sense? Here's x, and what does x equal? It equals negative 3y plus 3. So it says 2 times x, but x is really negative 3y plus 3. So this is what I want to do. I want to take this top equation, and I want to draw an arrow this way, and I want to put 2 times x, but instead of x, I want to put parentheses. And what am I going to write in there?
Negative 3y plus 3.
That's right, negative 3y plus 3, because that's what x is according to what we just solved. And then we have plus 5y, and I'm running out of space, I need to move it over, equals negative 5. Does everybody understand what I just did on step 1 and step 2? Step 1 was pick an equation, you thought about it, you picked the bottom one, you solved for x. Step 2 is to take that value, take that variable expression, this value right here, and plug it into the equation you have not used, which is the top one. If you use the bottom one, you're going to plug it into the top one. If you use the top one, you're going to plug it into the bottom one. So in this case, we take this and we plug it right into x, and this is what it looks like now. And if you look at step 3, that's just solve, all right? So once it's plugged in, all we need to do is solve, and what ended up happening is by us substituting the x value, which is now in terms of y, we don't have any more x's in this equation, and we could actually solve for y. So let's distribute 2 times negative 3y, that's negative 6y. 2 times 3, that's positive 6. 2 times, actually no, I'm sorry, let's not do that. My bad. I got a little carried away with the distributing. Let's just bring down the rest. We're going to bring down the plus 5y, bring down the equal sign, bring down the minus 5. And now let's combine like terms on the left side. There's a negative 6y and a positive 5y. That'll give you a negative 1y. Bring down the plus 6, bring down the equal sign and the negative 5. Let's solve for y by subtracting 6 on both sides. You will get negative 1y equals negative 11. Which means what? Y equals 11 if you divide by negative 1. And we're not done. Why? Because we only have the y. And when you solve for a system, you need an x and a y, correct? Now, if you have a y and you want the x, what do you do to find the x? You plug it in, right? I mean, that's logical. If I say x plus y equals 5 and I tell you y equals 3, then plug in 3 and solve for x, right? So we have a y right here. What we're going to do is plug it in, and at this point you've already used the bottom one, you already used the top, so you could plug it in to any one you want, either the top or bottom, in for y. So the 11 is going to go either into the top or the bottom, in for y, whatever you prefer. Which one do you guys want to use? Bottom one. So we're going to have x plus 3y, but we said y is 11 equals 3. So we're going to have x plus 33 equals 3. And if you subtract 33 on both sides, you're going to have x equaling negative 30. So think about this, guys. Your answer is x equals negative 30, y equals 11. In other words, negative 30 comma 11. If you were to have tried to graph this original system, then your point of intersection would be at negative 30, 11. Thank you. So it'd be very difficult to actually find this point of intersection. You need a super huge graph. So I hope you guys see the value of substituting. We're going to move on to another video on linear combinations, which is even better than substituting.